All right, so this will be the second session for the second part of your inheritance lecture. So I don't see any new questions from the Google Doc since yesterday, but I'll just make some announcement and then I'll open the floor for everybody to ask questions related to your inheritance lecture or any other things about the course. Okay, let me start with some announcement quickly. Your lecture week number 9, so that will be the final part for the inheritance lecture. It was released on Tuesday. Actually, this is not November 2nd. It should be November 9th. Okay, right? But anyway, so it was released about 2 days ago. And I want to draw your attention to actually two aspects for the lecture week number 9. Number one is about polymorphic method parameters. Right? Whenever you're declaring some input parameters for your methods, itself may have a reference type, which can be polymorphic if this involve some inheritance hierarchy. And because of the method parameters being polymorphic, you can have at the runtime so-called polymorphic collection. Polymorphic collection. It is a very important concept for you to understand, especially at the runtime. Exactly what it means to be polymorphic collection, but you will refer to the lecture for details. And number two is also relevant, which is about the polymorphic method return types. Okay, so whenever you're declaring some accessor methods, you want to give a reference return type. If that return type actually involves some inheritance hierarchy, in that case, it will be polymorphic. So what can be the runtime dynamic type for the return value? What can it be, right? So that's something you want to study carefully as well. So these are the two things I would like to highlight to you. You want to pay special attention to them. And also for the final part of your inheritance lecture, I also in the final part of the lecture videos, I summarize the so-called type checking rules for you. So that's something also for you to synthesize everything together. So it's about type checking rules. It's a little bit abstract, but it's very precise. So you want to study that carefully as well. Right? If you got any questions related to any of these, we'll discuss them next Thursday. Right? That'll be the topic for next Thursday. All right, and also your lab number 4 was also released on Monday. Okay, programmatically, I don't think it's really challenging because you're still just using the normal programming pattern that we have been using since the beginning of the semester. But those of you who might be struggling in the beginning of the semester, hopefully you are getting much better now since we practiced for so many times already. So for lab number 4, I want you to treat it more like a exercise to really practice inheritance. Right? Practice inheritance. So you really want to think about the analogy of the student example, right? Remember, we actually got students underneath, we got resident students, and also we got non-resident students. Think about how this particular hierarchy can be applied to your lab number 4. Think about it, right? And that will also help you to actually exploit notions such as polymorphism and dynamic binding, or even polymorphic collection. So for later on, when I go over the solution with you for lab 4, I'll try to highlight those points, but it will be very nice if you can think about those issues as well yourself. All right, the next item will be just about the upcoming 2 assessments in the final 2 weeks for the semester. Let's read the semester calendar together quickly, and then I will open the floor for questions. If you go back to your semester calendar in the lectures website, if you go there, you will see that we are currently here, November 11th. It is today. You can see this week and next week, we don't have anything due or anything that's coming for assessment. So I would say take this as a golden opportunity to really catch up with the lectures if you haven't been in pace with the inheritance lecture, right? I cannot emphasize that enough. And then in the final 2 weeks, we're going to have your written test number 3 and also programming test number 3. As usual, I'll release the guide about a week before the assessment occur. And then I'll give you some guidance about how you can get prepared and maybe some example questions as well. And also we got our exam, right? You can refer to the registrar office website for the exact date and time, right? That's something official. I have no control over that. So we will simply schedule the hours by the registrar office. Okay, so that's about what I want to say in the beginning. Before we dive into the technical contents for the lectures, do you guys have any administrative questions about the course? You can go ahead. Anyone? Okay, I'll pause for one more moment just in case you got any questions you want to ask, just about administrative.
Sorry, just a quick question.
Yes, go ahead, please.
Yeah, for lab 4, I know there's a slight change just for the variables. You told us to use, I think, private or protected.
Yes.
And you said there the change is reflected. Is it just like a change in instructions?
Yes, let me show it to you. Good question. The question was, there was a very slight change about the attributes you can declare in your lab number 4. Remember in the earlier labs, I said all the attribute must be private. So for your lab number 4, since you're kind of expected to use inheritance, so that's why protected is also allowed. Let me show to you where you can find that change. Let me show to you. Okay. Okay, so let's go to our E-class, okay, and I'll show you exactly where it was. If you go under the lab instruction for lab number 4, you will even see on November 9th, we actually got that update. But let's just go to instruction. Okay. Okay, I think that there are several places you can look at. Okay, several. Let me just point to you the most relevant part. Okay, give me a moment. I'll find it out. Okay, maybe not here. I think something about the attributes must be private or protected. Let's see if I have missed that. Give me a moment. Okay, there's a problem itself. And then I may have already missed that. Okay, let me just try to see if I can search for that. Okay. Okay, there we go. Okay, if you go to page number 3 over here, so page number 3 is under the requirements of this lab. Okay, you will see here all the attributes you declare must be either private, like earlier labs, or if you decide there are certain attributes you want to be shared among the parent class and also child classes. In that case, they should be protected. As we said in lecture week number 7, remember we spoke about the visibility of the attributes. We talked about the 4 possibility, if you try to recall, right? Either you got private, or if you got no modifier, or if you got protected, or you got public, right? So these are the 4 modifier statuses you have to be familiar with, which we spoke about. If you got a question about it, you can still feel free to ask me, maybe later. Okay, but the attributes, it can either be private or protected. And also about methods, if you want to create extra methods, you can also feel free to do that. In that case, the method can be either public, if other classes have to use it, or private, if only that particular class wants to use their helper method. Or it can be protected method. In that case, the method will be inherited to the child classes as well, right? You got different choices. Okay. So does that answer your question? Maybe?
Yeah, like in terms, yeah, okay, yeah, it does. Okay.
Okay, good. Yeah. And one more thing I want to point out. Okay, so this is also important. So please make sure you don't add any class that is not required by the starter test. I do understand to really solve the problem, there might be multiple ways, and one of the ways may be to create some extra classes that's not required by the JUnit test. But for the easiness of grading, so please don't violate these requirements. Any class that's not really hinted by the JUnit test classes, you shouldn't put it into the model package. All right, just to remind you, this is nothing new, right? That's something that's already there since forever. Okay. All right, so any other questions related to administrative issues of the course? For your programming test number 2, right? The TAs is now working very hard on that, but please understand that we actually got a large number of submissions to look after, and then even though we are doing auto grading mostly, but there's still actually submissions which got some errors that we need to look into manually, like missing files or compilation errors, or maybe some other violation which the TA has to look at that individually. I will try to ask the TA how it is going, maybe after the office hour today, and then we are hoping that we can get it released by the end of tomorrow. I know tomorrow is a withdrawal deadline, I'm very aware of the deadline for you, so I'll try. I cannot really promise, but I'm trying my best to get a programming test 2 released maybe sometime tomorrow. Okay, good, good. Yeah, I'm thinking about I'll put maybe more priority to programming test 2 as opposed to lab 2 and lab 3, since programming test 2 got more percentages. So if you want to make a decision, maybe programming test 2 will be better for you. All right, anyway, I'll keep you posted. Right. All right, guys, any other administrative question, please? Anyone? All right, hearing none, you can still ask me any point during the Q&A. That's okay. Okay, so now I open the floor for any questions you have related to lectures, especially maybe the part 2 for the inheritance, like a typecasting, instance of, and also, okay, before you guys are still thinking about what you want to ask me, let me just shift your attention to this diagram over here, right? For those of you who have already started lecturing, maybe have seen this diagram already. Let me show to you. Right. All right, so we're talking about under week number 8, right? If you go to the notes, the written notes over there, right? I want to show you one particular diagram that's really important. You want to make sure you also review that diagram for your written test and also exam. It's very important, right? Let me show to you. That one is about the different categories of the classes when you try to do typecasting. Right, so almost there. This one here, okay? Of course, this one looks a little bit sophisticated. That's because I kind of developed from scratch in the lecture video. So you want to make sure you watch that lecture video carefully. Basically, whenever you have like a variable assignments over here, you have certain static type, you have certain dynamic type, and given these two types, static versus dynamic, and also given some type inheritance hierarchy in the context, you should be able to derive 4 categories of classes, right? Either the class that will compile or the class that wouldn't compile. And then for those classes that will compile, you can further subdivide into 2 subcategories, into either either the class cast exception wouldn't occur, or the class cast exception will occur, right? So these are the 4 categories of classes you want to make sure you understand. Of course, you don't really want to just memorize. That may not lead you very far, because I think the principle I'm really trying to show to you that hopefully you will learn by heart is really something that will definitely will be applicable beyond this course. Whenever you're programming any OOP, the typecast rule is really the same. It's really consistent, not just specific to Java. All right. That's something I want to encourage you to really review or study as soon as possible. All right. Okay, so I'll pause now and then to see if you guys got any questions. All right. If you got a question from earlier lecture, that's also fine. So John, do you have any question today? Maybe we can start by you in case you have one.
Sorry, I just had a question. In one of the parts, you spoke about like protected methods.
Mm-hmm.
So protected methods mean we have package access and we have like child or like
That's
child
correct.
access as well.
You can think about protected methods are just like a protected attributes. Yes, indeed. So you can think about protected methods will be available to all classes in the same package, and also subclasses even outside the package. Make sense?
Yes, it does. Okay.
Very good, very good. Yeah, but John, of course, I think that's a principle, but feel free to try, on the Eclipse to really confirm, right? Yeah, as I said to your fellow students from yesterday in section B, if you are still behind in the lecture, I really want to encourage you to really catch up because I cannot really do the study for you. I can only record the lecture, so please. And then once you study carefully, you will have more questions for me. All right, John, go ahead.
Okay, so also I think like a while back when we were starting like to look at the equals method, and we were looking at let's say not setting the whatever we take in as a parameter. Like we would not setting it as object, but setting it as specific, like specific class we're dealing with. Can we talk about how to like kind of deals with classing exceptions, because when versus you know what I mean?
Okay, so John, I think as far as this course is concerned, you can assume that whenever we talk about equals method, I don't want to, the reason that I talked about last time, okay, let me just say this. Okay, let's say this. Let's say if we have a class over here, let's say for person over here. And we can safely assume, just for the context of this course, whenever you want to override the equals method, what you do is you simply override the default version that's inherited from the object class, which will be public Boolean equals, and you're talking about the parameter type over here. You can assume that it's always going to be just objects, and then obj. And of course, the definition, that's something we spoke about in the earlier lecture, right? And you can also refer to yesterday's recording, which I briefly revisited about part of it, where you can use the get class method, right? So I would say, as far as this course is concerned, this is the version you have to worry about. Okay, I think that's good enough. You might be talking about, for example, can we have something like maybe public, let's say Boolean over here, and also equals. And then can we put some static type for the parameter over here that's actually lower in the inheritance hierarchy, that's more specialized. For example, I can simply put person over here, and then maybe just say other over here. Okay, so this is indeed possible, but I wouldn't. I decided not to cover this in this course because it involves an extra layer of complication especially to discuss whenever you want to decide which version of the equals method to really call. Not only that, you have to look at the context objects, the dynamic type for the context object for dynamic binding, but also you want to see what's the type for the arguments that's being called. For example, if you got, let's say person one, let's just say object one, object two, right? If you got object one dot equals object two, for example, right? Let's say you got these two. Let's got this particular method called. In general, if you also got this method in the context, then it becomes quite complicated, because not only that, you have to look at the dynamic type for object one, but also you want to look at the static type also for object two in order to know which one to actually call. So I wouldn't really want to go into that complication, because I think the standard practice for Java programmer is to just override this particular method, in which case you're going to deal with all the possible cases for the parameter. I think that should be enough. So going into this will be in some way confusing. So that's why I didn't really go into it.
So when we do get class, we get access to the dynamic type. And
which one?
That for
static class. So yes, this one will get access to dynamic type. Yes, that's correct.
Dynamic type. And then we said, since the static type only allows us to get access to whatever attributes we're allowed.
Correct.
So is there a way to directly get static type, or no? Is that this what makes
it? Since we only talk about this version over here, you can see the static type for OBJ is only objects. So that means the only thing we can expect on OBJ is just whatever that's available in the object class. In this case, for example, if you say obj dot something over here, so what can we expect? Okay, so here we can only expect what's declared. We don't need to say accumulated, because object is already the top of the hierarchy, as we said before. Object is simply the parent class for every class implicitly in Java. What's declared in objects, right? So now, let's say, for the sake of example, let's say here, let's say we got integer, let's say age, right? Let's say every person has an age. In that case, if you say obj.age, it is not going to compile, because age is not defined in the static type for obj, which is objects. That's what we said, even in the equals lecture. But now, since you understand about expectation and static type, so now this should make more sense to you. So that's why you have to make sure the dynamic type for this. Let me just maybe just write it down again. So I think, guys, I think for those of you who might have some confusion of the equals method earlier, so now you may just want to revisit parts of that, especially about the get class line that we spoke about. So now that you have more knowledge about inheritance. Okay, let's now just revisit what we wrote over there. Okay, quickly. Over there, we said something like, if this dot get class, right, is going to return the information objects. If that's not the same information object as obj, which is referring to the parameter dot get class. In that case, we know that we are comparing like an apple with banana, right? They are not compatible to be compared. We'll simply return false. All right, so now here you can see this part over here is going to get the dynamic type of this, the context objects. And over here is going to get the dynamic type of obj, the parameter, right? So now we are saying that if their dynamic types happen to be the same, then you then of course you can actually do the cast, right? So here you're saying that if evaluated to false, in that case we will be able to do some casting. So we can say person over here, and then maybe other, and then is assigned to some cast version. So this will be person, and then obj. And this will guarantee this is not going to run into class cast exception, because since we evaluate this particular branching condition earlier, and that one we evaluate to false, so that means this part over here must be equal, meaning that this, which is a person, must have the same dynamic type as obj, which must be also a person. In that case, given that obj dynamically is a person, we can definitely cast that into a person. A person can definitely fulfill the expectation for a person itself. So that's why this cast will be okay. Right? So that's basically linking to what you learned earlier about the equals method. Does it make sense?
Yes, it does. Can I ask a second question?
You can. Yes, you can.
Yeah. So when let's say we have a hierarchy of like when we had student and like resident student, and if we're using like an equals method in the resident student, and we call super, but the student itself doesn't have an overloaded equals method, does that just go on to the next level and go to objects?
Very good. So John, okay, sorry, I'll let you finish first before I respond.
That was it.
That was it. Good, very good. So John, you know what? I think it's a very awesome question, but I will encourage you to move to this part of the lecture. That's exactly what's being spoken about, right? Let me just talk to you briefly about it, right? So I think what you just said, let's say, let me just do two things over here, because that's something I talk about another example in the lecture. Let's say we got, students over here. And if you remember, actually, that's also one of the exercises I put for week number 9 lecture. You will see that to actually override the equals method for resident student and non-resident student. You will see when you go to the lecture. Let's now assume the following. Let's say here the equals method is overridden, right? Let's say it is overridden. Maybe that one is simply going to compare not just the name and courses, but also to compare discount rate for the two non-resident student objects, right? And also the resident students also overrides their own version of the equals method, in which case they might compare not only the number of courses array, but also the premium rates. That's also overridden. And let's say in the student class, we do not choose to override the equals method that's inherited from the objects, right? So we know that implicitly, every class actually inherits from the object class. And the object class actually got the default version of the equals method, which will compare just the reference equality, right? Just compare the references between this and also obj. So let me now say, for example, let's say if we got, students over here as new, and then students. Oh, actually, I can do this. Let's say new. You know what? Let's make it more interesting. Let's say for whatever reason, let's say for NRS, we don't overwrite. Let's say, okay. So let's say here's the situation. We only override the equals method for resident students, but for NRS, we simply want to use whatever that's available in students, in which case it's going to be inherited directly from equals. Okay, let me now give you some example here. Let's say new resident students. Okay, so maybe some argument value over here. Okay, let's say S1, and also students S2 will be new non-resident students over here. All right, apparently you can see these two objects now should be very natural to you. You should really always, when you see some substitution or variable assignment, think about what's the static type and what's the dynamic type. The static type for S1 and S2 are simply just students. Dynamic types are different. One is resident students and the other one is non-resident students. Okay. So now here, maybe I'll pose the question to John first, since he initiated the question. Let's say we do S1 dot equals S2 versus S2 dot equals S1. Right? Let's say that's what we have. Okay. So now in this case, John, I'm not asking about it whether it's going to be true or false. That's not what I'm asking. I want to ask about which version of the equals method is going to be called. Okay. What about for number one?
So for number one, S1, the context object is so it's a resident student, so calls the overwritten one from resident student.
Over here, right? Very good.
Yep.
Okay. So very good. Awesome. That's exactly right, John. I think that it's really important to kind of show to me your reasoning process, because in the exam or written test, most likely the exam, you might be just asked about which version of the method is going to be called. You have to say not only the answer, but also to justify why the answer should be the case. So what you said was exactly correct. You're going to say this. Okay, so the question will be which version of the equals method will be called. Your answer should be this version should be called, that's overridden resident student, because the context object S1 has dynamic type resident students. So like what you said, okay? Overridden version in RS, because the context objects S1 has dynamic type resident students. Okay, that's a complete answer. Okay, so John, if you can help us out, what about second? What about number two? Which version?
So second, the context is non-resident student, but non-resident student doesn't have an equals method, so it just goes to the default from the object.
Right, that's correct. So what? For this one here, I will tell you what how you should justify it. It's pretty much what you said, but I think also for you will see more precisely the reason when you actually get to the final part for week number 9, which you will eventually go into. Okay, so let me say this one over here. So this one is going to invoke the default version of equals in objects. Yeah, that's the correct answer, but how do we justify it? Because none of the ancestors of NRS, which is the dynamic type of the context objects S2, overrides equals. So what I meant was, you can see here, this is the dynamic type for S2, right? And then along the ancestor path, in this case, including itself and also students, none of them actually overrides the equals method. So that's why it's simply just going to use the default version that's inherited from the object class. So that will be the complete answer. All right. So John, does it make sense to you so far?
Yes, it does.
Right. Let me just say one more thing, and then I can take the other question. Okay, let me say one more thing. So when you go to week number 9's lecture, right, if you go to the notes, you will see that it was actually discussed as the last example. I lost here. Okay, so we actually talk about overridden methods and dynamic binding. And you'll see different scenarios like a 1, 2, and 3. That's something you can review as well, just to reinforce. It's a different example. Okay. All right. Any more questions? Anyone?
Sorry, I saw that we said ancestors. None of the ancestors of NRS has overridden equals method.
So none of the none of the ancestors for NRS. You can see ancestor. Remember, ancestors include the class itself. NRS does not override equals, and also student does not override equals. So that's why.
So if student did override equals, we'd go to that one, not the
if one of the ancestor for NRS, the closest one. If the closest let's say if there are multiple ancestor for NRS that actually overrides the equals method, which one should we choose? As we said in week number 9, you should choose the closest ancestor. But in this case, none of the NRS and also or student actually overrides the equals. So that's why we're going to use the default one.
Okay, I understand. Sorry about that.
Good. All right. Yeah, for example, I don't mind showing that again. You can see here, let's say, for example, you can see here we got this inheritance hierarchy. I'll just touch upon briefly, but you can see the detail when you see the lecture video. Let's say we got inheritance hierarchy A, B, and C, and of course A implicitly inherits or extends objects. Let's say C itself, C is the dynamic type for the context object for the equals method. Okay, C does not override equals, and let's see along its ancestor path, is there any ancestor or ancestors actually override the equals method? In this case, only B. So B is the closest ancestor of C, the dynamic type, that actually overrides the equals method. That's why we're going to choose it. We're going to choose this one rather than choosing this one. And abstractly speaking, you can think about it's more like a shadowing idea, right? We say that if somehow the parameter name of your method has the same name as the attribute, it's going to shadow the attribute name. Similar, if one of your ancestor, the closest one, actually overrides the equals method in some way, it shadows any other ancestor, any further ancestor, or the object class equals method, right? So that's why we're going to take the closest one. Okay. It's a similar idea. Okay. Okay. All right. Any more questions? Oh, one thing I can point to you, maybe you're still thinking, right? Let me just point one thing to you, if I may. If you go back to, let's say, the recording from yesterday, right, November 10th, yesterday, I want to point to you in case you're interested. If you go to that recording there, okay, I'll point to you the part you can go. We still talk about, okay, we talk about some written tests. Well, that's not related to inheritance, but anyway. I want to refer to you this one over here, these two, this one specifically, like a new example on casting. I think one of your fellow students was asking about if I can give some new example for upward versus downward casting. I think that one there, actually I talk about some new examples, similar, but I think every example is similar in a way, as long as you understand the principle. But if you want to look for new example, you can look for this part, right? That might also help you. All right. Okay, any other questions? Normally I think the Thursday session, you guys got more question than the Wednesday student, but it seems like this week maybe the opposite, but that's okay. I mean, maybe you guys will have more question maybe next week. Okay, I'll pause for one more moment just to see if you guys got any more questions. If you don't have, then I'll let you go earlier, and then we can wait for next week. Okay. But it's really your time, so I want to make sure you're okay, at least for now. Okay, I pause for one final moment to see. But if you don't have question because you haven't really gone through the lectures, that's another story. So please do that as soon as you can. Otherwise, you will find the study more difficult, more challenging. If that's getting too close to the written test or to the exam. I don't need to mention that so much to you, right? It's really important to note. All right, hearing none. Yeah, okay. So we might just end the session earlier today, right? I still have my office hour today at 3 p.m. If you want to speak to me, feel free. All right. Otherwise, I'll see you next Thursday. All right. Okay. Okay. Let me see. So, John, I think for your question over here, that's a little bit kind of off track. Maybe just drop by my office hour, and then we'll talk about it. All right. All right, guys. Okay, I'm gonna end the meeting now.